Characteristics of sustainable or green architecture. Introduction. In a world facing climate change and rapid urbanization, sustainable architecture, also called green architecture, stands at the center of modern design, thinking it's not about aesthetics or fashion. It's about responsibility, creating buildings that reduce environmental harm while improving human life. Sustainable design seeks balance between nature and technology, efficiency and comfort, and innovation and ethics. The philosophy is simple. Buildings should work with the environment, not against it. It's architecture that saves energy, uses resources wisely, and supports both ecological and human well-being. Key characteristics of sustainable or green architecture. The core principles every designer should know. Energy efficiency and passive design. Energy efficiency is the foundation of sustainable architecture passive strategies. Reduce dependence on mechanical systems by using orientation, shading, insulation, and ventilation. Windows face the sun for warmth in winter, while overhangs and louvers block heat in summer. Natural airflow, daylight, and thermal mass help maintain comfortable temperatures with minimal energy use. Well-designed passive building performs like a living organism, adaptive and self-regulating, renewable and recycled materials. Sustainable buildings rely on renewable, recycled, or locally sourced materials. This lowers embodied energy, the energy used in production and transport. Materials like bamboo, reclaimed wood, recycled metal, rammed earth, and low-carbon concrete reduce emissions while maintaining durability. Prefabricated systems also minimize waste and allow efficient assembly. Every material decision becomes part of the building's environmental story. Green roofs and living walls. One of the most recognizable features of sustainable architecture is the green roof or living wall. These systems regulate building temperature, absorb stormwater, and improve air quality. They create miniature ecosystems that cool cities and restore biodiversity beyond their technical value. Green roofs reintroduce nature into dense urban environments, improving mental well-being and reconnecting people with life. Water conservation and management. Water-sensitive design treats every drop as valuable. Sustainable buildings often include rainwater harvesting, gray water recycling, and efficient plumbing systems. Permeable pavements and landscape drainage areas help manage runoff and replenish groundwater. Together, these strategies ensure that the building participates in, rather than disrupts the local water cycle. Renewable energy integration. Green architecture isn't only about saving energy, it's also about producing its solar panels. Wind turbines and geothermal systems are often integrated into the architecture itself. Building forms are shaped to maximize solar gain or optimize airflow for turbines in advanced cases. Buildings become energy positive, generating more power than they consume. Here, sustainability becomes both form and function beauty born from performance. Adaptive reuse and longevity. True sustainability values what already exists. Adaptive reuse, transforming old structures for new purposes, reduces waste and preserves cultural memory. At the same time, new buildings are designed for flexibility and longevity, allowing them to evolve as needs change. Durability replaces disposability, making sustainability a long-term mindset rather than a temporary feature. Human health and comfort. Sustainable design also prioritizes people, natural light, fresh air, non-toxic materials, and visual access to greenery all improve comfort and productivity. This human-centered approach often overlaps with biophilic design, creating environments that enhance well-being while reducing stress. Sustainability, at its best, sustains both planet and people. Notable examples of sustainable architecture. Bosco Vertical, Milan. Italy, Stefano Borri Architetti. This vertical forest reimagines high-rise living, covered with over 20,000 trees and shrubs. It filters air, absorbs CO, and provides thermal insulation while visually transforming the skyline into a living ecosystem. The Edge, Amsterdam, Netherlands, PLP architecture. Among the world's most energy-efficient office buildings, The Edge uses solar panels, rainwater collection, and smart automation To reduce waste, its intelligent systems balance lighting, temperature, and energy use in real time. One Central Park, Sydney, Australia, Jean Nouvel and Patrick Blank, famous for its green facades and heliostat mirrors. This project combines vegetation, renewable power, and recycled water systems to create a model of dense yet ecological urban living. How sustainable architecture is affecting modern design. Sustainability has transformed architecture from an art of construction into an art of conservation. It's redefining how buildings are designed, built, and operated, from small homes to megacities. Energy modeling, digital twins, and performance-based design are becoming standard tools. Certifications like LEED, BREEAM, and WELL have made sustainability measurable, and accountable governments now require green standards for new developments, embedding sustainability into policy and practice. But the deeper change is cultural sustainable. Architecture teaches us that design is not just about creating spaces. It's about shaping behavior, reducing impact, and building resilience. As cities grow, sustainable design offers the only viable future, architecture that sustains both life and the planet. Characteristics of Parametricism architectural style. Introduction and core philosophy. What if buildings could evolve like organisms, adapting, flowing, and responding to their environment through pure mathematical logic? That vision gave birth to Parametricism, one of the most influential architectural movements of the 21st century, coined and championed by Patrick Schumacher of Zaha Hadid Architects. Parametricism emerged as the natural successor to modernism and deconstructivism, but with a digital soul, where modernism prized simplicity and function, and deconstructivism celebrated chaos and fragmentation. Parametricism introduces a new kind of order, one governed by algorithms, relationships, and continuous variation at its core. Parametricism is about designing with parameters, variables that define geometry, form, and structure. Instead of manually drawing each line, the architect sets rules and relationships in digital software, and the form grows organically from those constraints. It's a design philosophy rooted in computation, fluidity, and interconnectivity. Doesn't imitate nature, it operates like it, producing organic, fluid, and futuristic forms that feel alive, responsive, and in constant motion. Key architectural features of Parametricism. To design in this style, it's important to understand the core features that define its aesthetic and logic. Algorithmic, form generation. Parametricism is powered by data. Every curve, surface, and connection is generated through algorithmic relationships, not arbitrary lines. This allows architects to manipulate shape, structure, and performance with mathematical precision. Form becomes the result of process, a direct expression of the system behind it. Fluid, continuous surfaces. Forget corners and flat planes. Parametric architecture thrives on smooth, flowing transitions between walls, ceilings, and floors. Spaces merge seamlessly, creating a sense of movement and coherence. A continuous spatial experience that mirrors natural forms like waves, dunes, or bone structures. Responsive and adaptive design logic. One of the key powers of Parametricism is its ability to respond to external inputs, sun angles, wind flow, human movement, or acoustic data. Through computational modeling, the design adapts to these parameters in real time, allowing architecture to become performative and context-aware. Complex geometries made constructible thanks to digital fabrication and advanced modeling tools like Grasshopper, Rhino, and Maya. Complex geometries once impossible to build are now achievable. These tools allow precise control over curvature, structure, and material performance, translating organic design directly into fabrication. Data hierarchical variation and systemic order. Parametricism isn't random. It's governed by a systemic coherence, where every component is related through. Scale and pattern elements vary continuously, but remain part of a larger logic. This creates visual unity across highly complex compositions, an ordered complexity that feels both futuristic and natural. Integration of structure and skin. In traditional design, structure and facade are separate entities in parametricism. They merge into one integrated system, often with structural ribs or exoskeletons following the flow of the surface. This creates expressive architecture where the skeleton and skin speak the same design language: futuristic and organic aesthetic. Parametricism's aesthetic is unmistakable, fluid, organic, and dynamic. It rejects repetition and static symmetry, embracing continuous morphing forms that seem to move even when still. These designs often evoke a sense of future, not through ornament, but through computational purity. Notable examples of parametricism. Parametricism has shaped some of the most iconic and influential architectural works of our time. The Beijing Daxing International Airport, designed by Zaha Hadid architects and ADP engineering, translates parametric principles into a massive scale, organizing circulation, light, and form through algorithmic flow. The Yas Hotel in Abu Dhabi by Asymptote architecture demonstrates how a dynamic facade, driven by digital modeling, can produce both beauty and performance. Using a fluid shell of steel and glass that wraps around two towers and a racetrack and UN Studios Mercedes-Benz Museum in Stuttgart reveals how parametric logic can inform spatial sequencing, spiraling ramps and voids, derived from circulation algorithms rather than intuition alone. Each of these buildings demonstrates how computation enables architecture to become a living system, where every element has a reason, a rule, and a relationship. How parametricism is affecting architecture. Today, parametricism didn't just change how buildings look, it changed how architects think. It replaced static design with process-based thinking, where form emerges from logic rather than artistic impulse. This shift has influenced everything from urban design to furniture, transforming architecture into an evolving ecosystem of data and adaptation in practice. Parametricism has led to smarter, more responsive environments. Architects use algorithms not only to generate form, but to simulate performance, optimizing light, airflow, energy use, and even human experience. It has also reshaped the aesthetics of the modern city, where once we saw repetition and rigidity, we now see fluid skylines, adaptive skins, and continuous morphing geometries that reflect the digital age's rhythm. But perhaps most importantly, parametricism has opened architecture to new collaborations between designers, coders, engineers, and robotic fabricators. It's a truly interdisciplinary movement, where architecture is no longer drawn, it's computed, grown, and evolved. Parametrism isn't just a style, it's a paradigm shift. It represents architecture's transition from mechanical precision to biological intelligence, from fixed form to fluid adaptability. We move further into the age of AI, automation, and environmental data. The principles of parametricism will only deepen integration, responsiveness, and continuous transformation. Characteristics of Blobitecture architectural style. Introduction and core philosophy. What if buildings could flow like water, bend like clay, and breathe like living organisms? That's the vision behind Blobitecture, one of the most expressive and fluid architectural movements of the late 20th and early 21st centuries, emerging in the digital age. Blobitecture, short for blob architecture, celebrates smooth, bulging, and organic forms that seem to defy geometry. It's a design language shaped not by rulers or right angles, but by algorithms, computer modeling, and 3D software that allow architects to sculpt freely in digital space. The philosophy behind Blobitecture is simple yet revolutionary. Form follows emotion, not function. Instead of the rigid structures of modernism or the fragmented chaos of deconstructivism, Blobitecture seeks to capture life and motion to make architecture appear as if it's growing, morphing, or even melting. It's an art form rooted in digital freedom, made possible through parametric design and computer-aided manufacturing. The architect becomes a sculptor of the virtual shaping buildings that blur the boundary between nature, technology, and imagination. Key architectural features of Blobitecture. At the heart of Blobitecture are a few defining design elements that every architect or designer should understand if they want to work in this style. Fluid, amoeba-like forms. Blobitecture rejects the straight line, Buildings take on bulbous, fluid, and biomorphic shapes that feel organic, as if they've been shaped by natural forces rather than human hands. Think of rounded surfaces, flowing transitions, and undulating forms that resemble water droplets, clouds, or even living tissue. Smooth, seamless surfaces. One of the most recognizable features of Blobitecture is its continuous, skin-like surfaces. There are no sharp edges or clear separations between walls, roofs, and floors. Everything appears to merge and flow. These surfaces are often made from glass, steel, or composite materials, giving the building a futuristic, almost liquid sheen. Advanced digital modeling and fabrication. Blobitecture couldn't exist without technology. Architects rely on parametric modeling, 3D scanning, and computer-aided design, CAD, to manipulate complex curves and surfaces with mathematical precision. Software like Rhino, Maya, and Grasshopper has turned freeform architecture from a fantasy into an achievable reality. Structural innovation beneath the surface. Despite their organic appearance, Blobitecture buildings are feats of structural logic. Hidden beneath their curved skins are steel or reinforced concrete, skeletons designed to support non-linear forms. Digital simulation allows architects to calculate load distribution in complex geometries, ensuring that even the most unconventional shapes stand firm. Light, reflection, and transparency. Light plays a central role in Blobitecture. Architects use reflective materials, translucent panels, and dynamic glazing to create buildings that shimmer, shift, and transform with time and weather. The result is an architecture that feels alive, constantly reacting to its surroundings. Much like a living organism adapting to its environment. Integration of environment and emotion. Blobitecture isn't just about appearance. Its goal is to create sensory experiences, spaces that feel immersive and fluid. The curved forms soften spatial perception, guiding movement naturally and making visitors feel enclosed in a dynamic, flowing environment. Notable examples of Blobitecture. Some of the world's most daring architectural experiments have been shaped by Blobitecture's philosophy. The Selfridges building in Birmingham, designed by Futurism, is perhaps the most iconic example. Its smooth, undulating facade, covered in thousands of aluminum discs, gives it a surreal, futuristic character. Part machine, part organism. Then there's the Kunsthaus Graz in Austria, often called the friendly alien. Designed by Peter Cook and Colin Fournier, it features a biomorphic blue exterior that contrasts yet harmonizes with its historic urban surroundings. Greg Lynn's embryological house project also represents the digital side of Blobitecture, an exploration of how architecture can evolve from computer-generated forms rather than traditional blueprints. And of course, Jan Kaplik's designs for buildings, like the Media Center at Lord's Cricket Ground, showcase how technology and creativity merge into an architecture that's at once functional and poetic. These examples prove that Blobitecture isn't just a style, it's a statement about freedom, imagination, and the limitless potential of digital design. How Blobitecture is affecting modern architecture. Blobitecture's impact goes far beyond a visual trend. It has reshaped how architects think about design, technology, and fabrication. By breaking away from orthogonal geometry, Blobitecture paved the way for parametricism and algorithmic design, which now dominate contemporary architectural thinking. What began as a radical experiment in the 1990s is now influencing how cities are being envisioned, from fluid museum forms to adaptive building skins that respond to climate and movement. Its influence can be seen in the works of Zaha Hadid, UN Studio, and MMAD architects, all of whom use fluid geometry not just for aesthetics, but to communicate motion, energy, and emotion in space. Blobitecture. He also redefined how buildings are made. Digital fabrication, CNC milling, and 3D printing technologies, once used in aerospace and automotive industries, are now standard in architectural production, thanks to the groundwork laid by Blobitecture's pioneers. In essence, Blobitecture changed architectures. It taught designers that a building doesn't have to look. Built it can look born. Blobitecture is more than a visual rebellion. It's a bridge between art and algorithm, nature and technology, emotion and precision. It challenges us to see architecture not as a static container for life, but as a living expression of it. This is the architecture of flow, the architecture of tomorrow. Architecture of tomorrow. Imagine standing in front of a building that doesn't look built. It looks grown. Its skin curves like a wave. Its structure feels alive. And its presence seems to belong to a future that has already arrived. That's the world of Neo-Futurism, a design movement that pushes architecture beyond steel and concrete into a realm where form, technology, and imagination blend into one. Born from late modernism and shaped by digital innovation, Neo-Futurism defines the architecture of our century. Expressive, data-driven, and emotionally charged. Let's break down the core, philosophy, and key characteristics of this visionary style, the design principles that guide architects to create the future today. Neo-Futurism is driven by optimism, the belief that architecture can embody progress. It rejects nostalgia and celebrates innovation. Instead of copying the past, Neo-Futurism envisions what's next. Its design philosophy revolves around three main ideas. Technology as a creative force, not just a tool, but a design partner. Form as emotion. Buildings should move people, not just shelter them. Fluidity and motion. Architecture should mirror the dynamic pace of modern life. Neo-Futurism treats architecture as an evolving organism, one that responds to its environment, adapts to technology, and inspires human imagination. It's not just about building structures, it's about building experiences. Now, let's focus on the main design elements, the core characteristics that define Neo-Futurism and guide its visual and spatial identity. Fluid, dynamic, and organic forms. Neo-Futurist design abandons straight lines and rigid boxes. Instead, it embraces movement, curved silhouettes, aerodynamic shapes, and flowing surfaces are central to its identity. These organic forms are not decoration, they're functional, aerodynamic, and symbolic of constant evolution. When designing in this style, think in terms of continuity. Walls that flow into ceilings, structures that merge with surroundings, and forms that evoke speed and life. Parametric and digital design. Neo-Futurism is inseparable from digital technology. Parametric design tools like Rhino and Grasshopper allow architects to experiment with complex geometries, test environmental performance, and generate forms through algorithms. This is where the human imagination meets computational precision. The result is architecture generated by logic and emotion combined. Every curve, every surface has purpose, reason, and rhythm. For designers, this means embracing technology, not as constraint, but as creative liberation to design what was once impossible to draw by hand. Expressive structural system structure in Neo-Futurism isn't hidden, it's celebrated. Beams, ribs, and skeletal frameworks become visible expressions of strength and motion. This principle can be seen in Santiago Calatrava's works, where the structure resembles a living being, wings, bones, or shells. The construction itself becomes sculpture, where every column, joint, and frame contributes to the narrative of motion. When designing, think of structure as part of the story, not a background element. Lightness and transparency. Of the most recognizable traits of Neo-Futurist architecture is the pursuit of weightlessness. Designers aim to make structures appear as if they're floating, gliding, or suspended in air. Extensive use of glass, steel, and composite materials achieves this visual. Lightness. Transparency blurs boundaries between interior and exterior, turning solid walls into dynamic filters of light and shadow. This emphasis on openness and illumination gives Neo-Futurist buildings a spiritual, almost ethereal quality, integration of nature and technology, while it may seem highly artificial. Neo-Futurism is deeply inspired by nature's systems. It seeks harmony between the organic and the theig, mechanical buildings that breathe, adapt, and respond to environmental stimuli through biomorphic geometry and smart materials. Architects design structures that mimic living organisms, adjusting to sunlight, airflow, and human movement. In this sense, Neo-Futurism isn't cold or mechanical. It's a technologically advanced form of natural design. Material. Innovation materials define the futuristic language of Neo-Futurism. Lightweight alloys, glass, titanium, and carbon fiber are preferred, materials that allow freedom of form and flexibility of expression. But beyond aesthetics, the focus is on performance, energy efficiency, durability, and adaptability. In the most advanced examples, facades act as responsive skins, adjusting light, temperature, and ventilation automatically. This is architecture that learns, evolving with its environment instead of resisting it. Emotional experience and symbolism, perhaps the most overlooked, yet defining feature of Neo-Futurism, is its emotional depth. Every form, curve, and void is designed to evoke a psychological response, wonder, curiosity, even awe. This emotional engagement is what separates Neo-Futurism from mere digital experimentation. Not technology for technology's sake. It's about using innovation to reconnect humans with space in a to see these principles come alive. Look at the world's most recognized neo-futurist landmarks: Heydar Aliyev Center, Zaha Hadid, Baku, Azerbaijan, a masterpiece of fluidity. There are no straight lines, no boundaries, just movement. It redefines how a building can express emotion through form. City of Arts and Sciences, Santiago Calatrava, Valencia, Spain, a skeletal wonder inspired by organic anatomy, both futuristic and natural. Mechanical yet human. Museum of the Future, Dubai, designed by Killa Design. This building represents data, humanity, and innovation, symbolizing an endless pursuit of knowledge. Its void at the center represents the unknown, the future itself. Each of these examples embodies one principle: form, function, and emotion united through technology. Neo-Futurism isn't just a style, it's a transformation in how architects think and design. It's redefining architectural education, pushing students and professionals toward computational design, sustainability, and emotional storytelling. Cities are beginning to reflect neo-futurist ideals with smart infrastructures, adaptive buildings, and data-integrated planning. The future it imagines is not cold or robotic, it's human, fluid, and alive. And neo-futurism is exactly that, the art of making the future feel alive. Imagine a building that breathes, that shifts with daylight, that feels alive. A space that not only shelters you, but restores you. This is Biophilic Design, a design philosophy rooted in one timeless idea: humans need nature to thrive. Biophilic design is not just an aesthetic approach. It's a way of designing spaces that reconnect us to the natural world, to light, air, water, vegetation, and organic forms. In this video, we'll explore the defining characteristics of biophilic design and how they transform architecture into living, breathing environments. The term biophilia means love of life. Biologist Edward O. Wilson introduced the concept to describe humanity's innate desire to connect with nature. Biophilic design translates this biological truth into the built environment. It seeks to design spaces that respond to human emotion and physiology, spaces that reduce stress, restore focus, and promote well-being. We spend almost 90% of our lives indoors, disconnected from natural light, fresh air, and organic materials. That detachment affects us more than we realize, mentally, physically, and emotionally. Biophilic design is the architectural answer to that problem. It rebuilds our relationship with nature through design that feels alive. Now, Let's explore the key characteristics of biophilic design. First, natural light and dynamic lighting. Natural light is one of the most fundamental elements of biophilic design. Daylight connects us to the passage of time, to morning, noon, and night. Architects use large openings, skylights, and reflective surfaces to allow sunlight to shape a space. Dynamic light, the way light shifts and changes through the day, keeps interiors connected to natural rhythms, supporting health and comfort. Second, connection to natural systems. Biophilic design acknowledges the cycles of the natural world: air movement, rain, seasonal change. Buildings that breathe, that capture rainwater, or open themselves to breezes, remind us that architecture and nature are not separate systems. Feeling a change in temperature, hearing the sound of wind or water, these experiences make a space feel alive and responsive. Third, use of natural materials. Natural materials like wood, stone, bamboo, or clay create a tactile bond with the earth. They age gracefully. They carry scent, warmth, and texture. Unlike synthetic materials, they reflect authenticity, reminding us of nature's imperfections and beauty. Biophilic design favors materials that are renewable, locally sourced, and true to their environment. Fourth, the presence of vegetation and living systems. Plants are among the most direct ways to bring nature indoors. They clean the air, regulate temperature, and soften the acoustics of a space. Vertical gardens, rooftop greenery, and interior courtyards allow vegetation to thrive within architecture. Greenery blurs the line between interior and exterior, restoring our instinctive need to coexist with living systems. Fifth, water elements. Water calms, refreshes, and connects. In biophilic design, water appears as reflection, movement, or sound through fountains, streams, or rain features. It stimulates multiple senses at once, grounding the human experience in natural serenity. Spaces like Falling Water by Frank Lloyd Wright or Singapore's Jewel Changi Airport show how water can become the emotional heart of a design. Sixth, natural shapes and forms. Nature rarely uses straight lines. Biophilic design embraces curves, spirals, fractals, and branching patterns. These organic geometries mirror leaves, shells, and rivers, creating forms that feel intuitive and familiar. Such patterns relax the mind and add fluidity to spaces that might otherwise feel rigid or mechanical. Seventh, views and visual connection with nature. Even a view of trees or sky can transform mood and productivity. Visual access to natural landscapes, whether through a window, a courtyard, or an atrium, lowers stress and improves concentration. When architecture frames nature, it reminds us that we are part of something larger and more enduring. Eighth, spatial experience, prospect and refuge. Human beings instinctively seek balance between openness and protection. Prospect means the ability to see out, wide, open views that create comfort and awareness. Refuge means enclosure, cozy, shaded corners where we feel safe. When a space combines both, it satisfies deep psychological needs for exploration and security. Ninth, natural color and texture palette. Biophilic spaces draw color from the world around us. Greens of foliage, browns of soil, blues of sky and water, the gold of sunlight. These tones, paired with rough textures and soft light, create warmth and serenity. Natural colors are more than decoration. They communicate harmony and balance, 10th sense of place and ecology. True biophilic design respects its location. It reflects local climate, materials, and culture. A building in a desert uses shade and clay to cool. One in the tropics opens itself to air and vegetation. Architecture becomes an expression of its ecosystem, belonging to the land rather than competing with it. Across the world, remarkable examples demonstrate these principles in action. The Bosco Vertical in Milan, vertical forests transforming city air into a living canopy. The Khu Tek Puat Hospital in Singapore is designed as a healing garden, where greenery and water embrace patients and visitors alike. The Amazon Spheres in Seattle, workplaces surrounded by over 40,000 plants that enhance creativity and calm. The Isla La Villas Uluwatu in Bali, architecture that dissolves into the landscape through openness, stone, and air. And Frank Lloyd Wright's Falling Water, a timeless example of harmony between human structure and natural flow. Each of these projects proves that when design partners with nature, architecture becomes more than a shelter, it becomes an ecosystem. Biophilic design isn't about decoration or trend. It's about restoring a relationship that the modern world has forgotten. It reminds us that architecture is not meant to isolate us from nature, but to draw us closer to it. When a space captures the spirit of life, when it moves, breathes, and changes, we feel at home. That is the essence of biophilic design. To create architecture that feels alive, because it honors life itself. So the next time you enter a building, ask yourself, does it confine you or does it connect you? Because the best architecture doesn't just protect us from the world outside, it brings that world back in.